Okay, so today we're gonna dive into a really interesting event that's been in the news a lot recently. We're talking about the big earthquake that hit. Well, it didn't really hit Bangkok, but it sure did cause some problems there.
Yeah, you send in a ton of articles, reports, firsthand accounts,
Yeah.
all about it. So I think our mission here is to like figure out what exactly happened and more importantly, what it means for everyone, like what are the takeaways here?
Right, exactly. Because like on the surface, it's like okay, an earthquake in one place caused damage in another, but like why? Why
What's the dire?
Bangkok? Well, it all started on March 28th, so just a few days ago. This powerful earthquake hits the Sagoing region of Myanmar.
Which for folks who don't have like a map of Southeast Asia in their head
Yeah.
is
Hundreds of kilometers from Bangkok.
yeah, hundreds of kilometers away, exactly.
Yeah.
And looking at the USGS, they put the magnitude at a 7.7.
The Thai Meteorological Department actually said it was even higher. They measured it at 8.2. Yeah. There's always a little bit of variation, right, between different agencies, different ways of measuring, but either way.
We're talking a major earthquake.
Oh, yeah, a seriously powerful earthquake. But here's the thing that's crazy. Like, I mentioned it didn't hit Bangkok directly, but a 33-story building under construction in Bangkok just totally collapsed.
Yeah, in
In
Chattahoochee.
Chattahoochee. And we're talking confirmed deaths, a lot of people still missing. So, like, how does that even happen, from so far away?
Yeah, it's kind of mind-boggling, right? So, like, to understand this, we have to kind of dig into the nitty-gritty of what happened with this quake. So we know it hit on Friday, March 28th at about 1:20 p.m. Bangkok time, which translates to like 6:20 a.m. UTC.
Okay, so, like, right in the middle of the day in Bangkok.
Exactly. And the epicenter was, like we said, in Myanmar's Sagaing region, near a city called Mandalay. Like pretty close to Mandalay, actually, like 18 kilometers south of Sagaing city itself, and just 16 kilometers west of Mandalay.
So, like, pretty much right smack dab in between them.
Pretty much, yeah. And a really important point is that this earthquake had a really shallow focal depth, only about 10 kilometers underground.
Oh, wow. So, like, that energy is way closer to the surface than, like, a really deep earthquake, right?
Right. And that shallow depth plays a major role in how far and why the effects were felt.
Okay, so shallow earthquake, super powerful, happens hundreds of kilometers away, and yet a skyscraper in Bangkok just crumbles. That's just not something you normally think about. Like, how can a city be vulnerable to earthquakes if it's not on a fault line?
Right. And that's where Bangkok's kind of unique and I guess you could say unfortunate geological situation comes into play.
Because what's going on under Bangkok?
So basically, Bangkok is built on a very deep layer of really soft soil, mainly river sediment, and a big chunk of that is soft marine clay. And here's the thing. These soft soils, they kind of act like an amplifier for the seismic waves coming from an earthquake.
So, like, instead of the energy just traveling through, it gets kind of like trapped and magnified.
Exactly. They slow the waves down, but also make them much, much larger, which means the shaking is way more intense in Bangkok, even if the earthquake itself is really far away.
Wow. So, like, Bangkok's ground basically made a distant rumble into a much stronger jolt locally. That's crazy.
Yeah. It's almost like, imagine a giant bowl of jelly. You shake one side, and the whole thing jiggles way more than you'd expect.
Oh, okay, I get it. And then on top of that, there's the whole thing with resonance, right? Like, tall buildings have their own kind of sway.
Exactly. Tall buildings have a natural frequency they sway at. If the earthquake waves, especially those amplified by the soft soil, match that frequency, the building starts swaying like crazy, way beyond what it's designed for.
Yeah.
And we saw that with like the videos of water sloshing out of rooftop pools. That was resonance in action.
So it's just like pushing a swing at just the right moment. Each push makes it go higher and higher.
Exactly. And in the case of buildings, obviously, that's a really bad thing.
Okay, so we've got the shaping, the amplifying effect of the soil, the resonance of tall buildings. What about the actual damage and, the human cost?
Yeah. So the most tragic part of this whole thing is the SAO building collapse. That's the 33-story building under construction we talked about. It just completely crumbled. The immediate aftermath of something like this is always chaotic, right? Getting a precise count of casualties takes time. But early reports were estimating anywhere from 3 to 18 deaths, with many, many more still missing. Most of those casualties were from the SAO building site.
That's just heartbreaking. What about damage beyond that building?
So we saw reports of construction cranes that had just toppled over. Roads cracked and buckled. There were pictures of buildings leaning precariously, looking like they were about to fall. Authorities had to close the Din Daeng Expressway exit because of the damage. Another building near JJ Mall, a big shopping center in Bangkok, also partially collapsed. Even the Park Origin Thonglor Bridge was damaged. It was really widespread.
So this wasn't just like a few isolated incidents. This earthquake had a real impact on Bangkok.
Yeah, it definitely did. And the authorities responded pretty quickly, thankfully. Bangkok was immediately declared a disaster area. They mobilized rescue teams, including the military, and sent them out to help people and search for survivors. Structural engineers were also sent out to inspect buildings, and some were deemed unsafe for people to return to. The rescue operation at the SAO building was particularly challenging, and they actually had to halt it temporarily because the remaining structure was so unstable, they were worried about further collapses.
So it sounds like a pretty coordinated response considering the unexpected nature of the situation.
Yeah, I think so. They were definitely taking it very seriously.
Right. So we've talked about Bangkok's geology and how that magnified the impact of the earthquake. But let's zoom out a little bit. What's the bigger picture in Southeast Asia? Why are there earthquakes there in the first place?
So, Southeast Asia sits in a really tectonically active zone. It's right at the collision zone between the Indian and Eurasian plates, two massive pieces of the Earth's crust. These plates are constantly pushing against each other.
So like two giant continental bumper cars.
Kind of, yeah. And that constant pushing and grinding is what causes earthquakes in the region. This particular earthquake originated along the Seging Fault, which runs right through Myanmar. It's a major fault line, and it's a strike-slip fault, meaning the two sides of the fault slide horizontally past each other.
So like they're trying to move past each other, but they get stuck and then suddenly slip.
Exactly. And that sudden slip is what releases a huge amount of energy in the form of seismic waves, causing the earthquake. Now, even though Bangkok isn't directly on a major fault like the Seging Fault, its geology, that soft soil we talked about, means that it feels the effects of these distant earthquakes much more strongly than a city built on solid rock would.
So it's kind of unlucky in a way. Like it's got this double whammy of being near a seismically active region and having a ground structure that amplifies those tremors.
Yeah, unfortunately. And this isn't the first time Bangkok has felt earthquakes. There have been several in the past that were felt in the city, going back to the 1800s, like in 1839, 1975, 1983, 1988, and even as recently as 2011. But this 2025 event, this is the one that seems to have caused the most significant damage.
Okay, so earlier we were talking about the magnitude of the earthquake and how different agencies reported slightly different numbers. What's up with that?
Yeah, it can seem confusing, right? Like, why can't they just agree on one number? But it's actually pretty normal for different seismological agencies to report slightly different magnitudes for the same earthquake. They might be using slightly different methods of calculation or using data from different sets of seismometers.
So it's not like one is right and one is wrong?
Exactly. It's more about slightly different approaches leading to slightly different results. The USGS, for example, they typically use the moment magnitude scale, which is often considered the most accurate for large earthquakes. But other agencies might use slightly different scales or calculation methods. And that's okay. Different methods provide different pieces of the puzzle, and scientists can use all of them to get a more complete picture of the earthquake. For example, in this case, the Hong Kong Observatory specifically pointed to Bangkok's soft soil as a major reason why the shaking was so strong there and why that building collapsed. It wasn't just the magnitude of the earthquake itself, but also how that energy interacted with the local geology. And to add a bit more detail, the earthquake involved what we call strike-slip faulting. That means the two sides of the fault moved horizontally past each other, rather than up and down. And this horizontal movement can cause particularly strong shaking, especially when amplified by soft soil. The estimated shaking intensity in Bangkok was around level 5 on something called the modified Mercalli intensity scale, which means it was moderate shaking, definitely strong enough to be felt by pretty much everyone and to cause some damage.
Okay, so not just how strong the quake was, but how the land moved and the type of ground it was shaking all played a part.
Exactly. And it's worth noting that this earthquake, regardless of the exact magnitude, was the most powerful earthquake in Myanmar since way back in 1912. So we're talking about a really significant seismic event here.
So even though the earthquake itself happened a few days ago, it's not like everything just calmed down immediately after, right? There were aftershocks.
Oh yeah, tons of them. In fact, one of the biggest aftershocks, a 6.4, happened pretty soon after the main quake. And it wasn't just one or two. There were reports of over 70 aftershocks hitting the region, and some of those were strong enough to be felt all the way in Bangkok, which is obviously worrying because, buildings are already weakened from the main earthquake.
So it's like a one-two punch, and the aftershocks can keep people on edge for a while.
Definitely. There was even a 5.1 magnitude aftershock near Mandalay, too. And seismologists, the scientists who study earthquakes, they're predicting that aftershocks from this earthquake could continue to be felt in Thailand for another week or two.
So it's not really over yet. Okay, so to sum it all up, Bangkok's soft soil amplified the impact of a really powerful earthquake that occurred hundreds of kilometers away in Myanmar. And that led to serious damage, including, tragically, the collapse of that building. The takeaway here is that being at risk from an earthquake isn't just about how close you are to a fault line, it's also about what the ground beneath you is like.
Absolutely. Understanding the geological makeup of a city is crucial for figuring out how vulnerable it might be to earthquakes, even if those earthquakes happen far away. It's not just about being close to the source, it's about what's happening beneath the surface.
It's a really important lesson, and it makes you think, like, what about other cities around the world? Are there places that we think of as safe from earthquakes that might actually be more at risk than we realize just because of the type of ground they're built on? What happened in Bangkok is a reminder that we need to think about earthquake risk more broadly and not just focus on what's happening right beneath our feet, but also what's happening hundreds of kilometers away. It's definitely something to consider. Anyway, that's our deep dive on this topic. Thanks for listening.